This is Alan Schimmel, Editor-in-Chief of DevOps.com, and I am happy that we're doing another webinar with our friends at CloudBees. The title of today's webinar is Scaling Jenkins with Docker and Kubernetes, and today's presenter is Carlos Sanchez from CloudBees. Carlos is a gentleman has over 10 years or more of experience in the open source world. He's a member of the Apache Software Foundation, has contributed to various open source projects, including Maven, Fog, and Puppet. He's currently a senior software engineer at CloudBees, and he's the fellow who actually wrote the Jenkins Kubernetes plugin. I don't know how much more we need to say other than that, but Carlos is, the kind of people that make CloudBees and Jenkins today. Hopefully you can hear me.
Yeah, thank you, Alan.
Okay, I'm going to let you take it away from here, and if there's nothing else, I'll be listening and learning myself.
Okay, thank you very much, Alan. So, as Alan mentioned, I'm going to talk about Kubernetes today and Jenkins and how they fit together. And I'll talk at the beginning about Kubernetes and more at the end about Jenkins, and I'll do a demo at the very end, showing you an actual example of how these technologies can be used to improve your CI, continuous integration, continuous delivery pipelines, and how to run Jenkins at scale. So with that, if you know CloudBees already, I mean, we are the enterprise Jenkins company. We are contributing a lot of things into Jenkins and working with the community and building this Jenkins platform and improving your life, let's say the developer's life, on the continuous integration, continuous delivery fronts. So let me start talking a little bit about containers and microservices. Right. So Docker became really popular because it can standardize things that already existed for years, but Docker made it really easy to use. All the Linux containers, all these abstractions on top of file systems, users, processes, network isolation, and so on. Now, the question when people start using seriously Docker is how to actually run it at a decent scale, let's say. Containers are, at some point, you realize using containers at the scale is not trivial. Using Docker, you start using one host, then you figure out you need to use more than one Docker host, and it's just not trivial to scale. And another great quote I got from on Twitter. So Docker is also being depicted as that hammer that when you have Docker, everything looks like a nail, and basically Docker could be the solution for all your problems. Just ask what your problem is, and the solution is going to be Docker. Actually, for CI and CD, Jenkins in this specific case, Docker is a great technology and it's a really great fit and helps people use Jenkins in a best possible way, isolating a lot of the complex stuff that needs to be done during building, during CI, CD. A lot of help comes from the Docker project. So if you are familiar with Docker, also there's this repository, the Docker Hub, where there are official images and other images contributed by organizations or individuals. So I'm one of the guys contributing to the official Jenkins image, and we are building this. So it's an official Docker image maintained by the community, but it's on the official repository part of Docker. And this is one of the things that we're going to use later on today. So we are publishing LTS releases under the Jenkins repository. So 1.609.2, and I believe there's a new one in there. And you can see in there the Docker file, how it's built. But the interesting stuff is, like, this is the official one where all the others will derive from. There's also another repository called Jenkins CI/Jenkins, which is not the official Docker one, but this is provided by the Jenkins community, and this is the weekly build of Jenkins, packaged as a Docker container, as a Docker image. So you need something that is newer than the official image, you can use this one. And it basically uses the same Docker file, just a newer version every week. And another image that we are going to be using is the Jnlp slave, Jenkins CI/Jnlp slave. This is the when you use Jenkins and you have one master and multiple slaves run at a bigger scale, this is the image we're going to use. This image includes the Jnlp client library. Basically, when you start this image, it's going to connect to a master that you can point it to, and it's going to join us as a new slave to that Jenkins installation. So this is just an image with Java and the Jnlp client. And we are publishing all these images and updating them regularly, and they are quite used in our projects and outside there. So with all that, let me start talking about Kubernetes. Kubernetes is this project created by Google at the beginning, but joined by a lot of other companies like RedHat and CoreOS, and this is based on all the years that Google has this experience running containers at scale. So this is a new project. It's not something that Google was running, but it's based on their experience. And one of the core guys there working at CoreOS with Kubernetes, Kelsey Hightower, said at some conference, like, the design behind Kubernetes is also following this practice of how would you design your infrastructure if you couldn't log in ever, right? So how would you design all your services and everything that is running on your hardware so you can get information and be able to manage all that without having to SSH into individual machines. So this is I believe it's one of the powerful concepts that Kubernetes tries to solve and tries to make your life easier in this respect to manage infrastructure at scale. So Kubernetes is technically a container cluster orchestration. You can run containers across multiple hosts. These hosts are called minions. Previously were called minions, now they're called nodes, and provides a higher level API on top of all these hosts and Docker hosts. It works enforcing a state, so you basically define what your end state is, not how to get there. And this is important in a concept that we'll see later. And it also allows you monitoring endpoints, like checking if services are running and doing actions in those cases where they're not. So that's one of the characteristics of Kubernetes, that it handles the state and works to ensure that that state is always working. So you have a Kubernetes master, typically installation, Kubernetes master, multiple nodes, and you have containers being scheduled through the master, and the master defines or decides what nodes to run those containers into. So it orchestrates and schedules these containers to run across whatever number of nodes that you have. The master contains the API server that handles the scheduling and synchronization of the state across all the nodes. It uses etcd to keep the state, and also has this controller manager server that basically watches etcd and decides whether your state is being actually fulfilled, let's say, and do actions in case of if that does not happen. Each of the nodes will have the Docker server, so that's the main part of the node, but also has a kubelet service, which is a service that is running along the Docker server, and it's checking that the pods, and I'll talk about this later, the containers state is always the one that Kubernetes wants. It also runs a network proxy, a very simple network proxy that in new versions it may go away because it may switch to IP tables. It also runs etcd, and optionally it may run SkyDNS. These are optional services that Kubernetes can run. SkyDNS is like a distributed DNS service that will allow you to have names pointing to containers no matter where they are, and also optionally Elasticsearch and Kibana to get the logs of all these containers running on the different nodes. So you have one master node, multiple worker nodes, and Kubernetes does some special things like having two Docker servers sometimes on the master. Well, not actually sometimes, but always has a bootstrap Docker to start up the services, and then it has the main Docker server running the kubelet and all these other auxiliary services to keep the Kubernetes layer working. And on the worker nodes is whatever containers we are going to run, where they are going to be executed. So the master node is only like the brain of Kubernetes, where all the state and the scheduling takes place. There's a lot of providers, so you can run Kubernetes on Google Container Engine, JKE. This is like, I would say, is the main place or the canonical place where you can run Kubernetes, just because Google makes a big effort on having that working smoothly. And they obviously are the ones creating the project, and that helps. But there's a lot of people involved from other companies, and you can run Kubernetes on Azure or Rackspace, and you can also run it locally on your bare metal hardware, or you can use Vagrant for development. There's a lot of places where you can run Kubernetes right now. CoreOS too. I mean, there's Amazon, you name it. There's support for a lot of them. And creating a cluster in Kubernetes is very easy. So you choose what provider you want to use. In this case, I'm using Google Compute Engine. This would be using the command line. If you don't want Kubernetes, you just set these variables, how many minions or nodes you want, and run kube app, and it's going to go to the cloud, here to Google Cloud, and it's going to create all the instances needed, and it's going to install every service needed. The other option that I mentioned before with Container Engine, Google Container Engine, you can just go to the cloud, Google Cloud web console, and enter the name of the cluster you want, what zone, what type of machines you want to use, and the size, and it's gonna do that for you. And the examples I have them running on Container Engine, so you'll be able to see that later. And you can also use the command line, basically with the gcloud container, the same thing. You just create a cluster, what size, how many nodes, and it's gonna go and do that for you. Now, entering into the concepts of Kubernetes, So there's several, let's say, objects that define the Kubernetes API. One of them is the node that I mentioned before. This is the actual node where the Docker containers are going to be run, and you can query the Kubernetes API and get all sorts of information from that node. It's interesting stuff from here is getting like how many CPUs it's contributing to the cluster, how much memory, or whether the node is ready, what IP, and so on. And Kubernetes, the scheduler, is going to take this information when it schedules new containers running across nodes. One of the most important objects would be the pod, which is a group of containers, and with the guarantee that they are always going to run in the same node. So you can have like a web server and a caching server, or containers, both of them running inside the pod, and it's going to guarantee that they both are going to run together. And it also will have they also will have the same IP. Basically, they can refer to each other using localhost, and you can define environment variables for the containers, and you can use share volumes, which is the Kubernetes way to provide persistence to pods. So you can have different storage mechanisms. The basic one would be host-mounted directories, like with Docker, same concept. But obviously, that's going to work only if the pods are running on the same node all the time. But you can also have on Google Compute, can have data disks. Basically, they will be persistent across executions. And in AWS, you can use EBS volumes, you can use clusterfs, NFS, and a few others, and this is pluggable, so people can create their own. And another type of volume called secrets that basically runs as a RAM disk where you can store credentials and things like that you don't want written to disk. So when a client requests some pods to the master, the master will go on and take whatever number of nodes is running, decide where to put those pods, and is going to put them in the different nodes. And those nodes where Kubernetes is running, that's how the master is getting all the information from the node. The pod definition, it's basically all the objects on Kubernetes have this metadata, so you can assign a name and different labels, which is important later on to find pods or find services or containers. And then you define the spec, which basically says what containers to run and what volumes to use. In this case, I'm running the Jenkins image, the C. Sanchez / Jenkins Swarm image, and I'm exposing a couple of ports, 8080, 50,000, and I'm mounting a host volume into var Jenkins hub. So this is a simple example of how to run only one container on Kubernetes. Now, after pods, the other interesting model that Kubernetes provides is the replication controller. So you can say how many pods you need to run and pass the pod template of each of them, and you can tell Kubernetes to start 20 pods like this one. So just use a template and tell Kubernetes, I want 20 of these running. And Kubernetes is going to go in and take care of running that across all the nodes. So that's the part where I mentioned it enforces the state. So you say how many of them you want, and that's it. And it also supports a rolling update, which basically from the CLI you can say, I have 20 instances of these 20 pods running. I want to update one every 1 minute to make sure that I don't destroy all of them at once. And I want to update them, I don't know, to update to a new Docker image or whatever. And you could easily do that from the CLI. So when you say I want like 3 pods of type A and 2 pods of type B, the master is going to take care of running them no matter where they run in each node. You don't care about that. Kubernetes hides all that from you, and that's all good. And this is one of my favorite quotes from DevOps for that. That's why with replication controllers, if you make a mistake and you say to Kubernetes, run this in 100 of this, that's how you basically propagate the error in an automated way. That's pure DevOps. And the replication controller definition is very similar to the pod. You also have metadata associated to the replication controller, and then you have a spec with what containers you want in that replication controller. So in this case, what I'm running is a Jenkins swarm image. I'm saying run one replica only, and run it across Kubernetes, and mount this volume. Same thing as before with the pod, same volume mount, same container port. But in this case, I'm running this as a replication controller that happens to have only one instance. The other or last concept of Kubernetes, of the main ones, is services. Basically, when you have all these pods running across multiple nodes, you need to figure out where they are. So services allow you to do pod discovery. And every time you create a service, it's going to give you a new IP. So this is very particular about Kubernetes. You get a new IP per pod and a new IP per service every time you run them. And you can refer to that service by IP, and Kubernetes is going to route that IP to the pods that is running that service. And how did you choose which pods? Basically using labels, metadata associated with those pods and replication controllers. And on top of that, in some providers like Google Container Engine or Google Cloud and AWS, you can also tell Kubernetes to create an external load balancer. Elastic load balancers on AWS and the same concept of Google Cloud. And it will provide you external IP that will route directly to that service. And those pods that match the service definition. So basically, it's going to take all the inbound traffic and route it to the right place, selected by labels. And it's going to, if there's more than one place that matches, it's going to load balance across them. And the definition, in this case, I'm creating a load balancer. There's 3 types of services. One that is going to only expose the ports internally in the node that it's running. The other one is going to expose them across all the nodes in the cluster. And then there's the one that will create an external load balancer for you. So basically, I'm saying what I'm saying here is expose the port 80 outside. The service port 80 goes to the port 8080 of any pod that matches name equals Jenkins. And the same thing I'm doing for the port 50,000. In that case, I'm not switching ports. Port 50,000 publicly is going to go to the pod port 50,000. And this is basically the only thing I need to define the service. And Kubernetes has this very interesting way of doing networking. As I mentioned before, you get services that have their own IP. Every pod has its own IP. And the containers in each pod can talk using localhost. So how it manages this is on Google Cloud. It does it natively using the cloud. In other providers, it uses CoreOS Flannel to create an overlay network in those providers that don't need support natively. And every machine is assigned a full subnet So every container, that's how every pod can get its own IP. I mean, it's a bit complicated at the beginning, but it helps a lot to reference if specific pods by its own IP, and you get full network isolation that way between different pods. And you can also run Kubernetes cluster, a very easy test of Kubernetes using Docker Compose. I have this on the examples, and sometimes I do this for the demos. It just runs in one node, but for today I'm going to run it on Container Engine so you can see it across multiple nodes. Okay, I'm now talking about more how this can help people using Jenkins, right? So there's an initial solution for somebody that hears about Kubernetes that is basically saying, I can run the Jenkins master in a pod. For instance, in Container Engine or in Google Cloud, I can make that master home folder have a backend, the storage backend be a Google persistent disk. That way, I don't lose any data in any situation, right? If the container dies or the pod dies or anything like that. And it's always going to be there if it gets rescheduled if I run it later on in a different node. And for controllers, for the slaves, I can run them as a replication controller, basically saying how many slaves do I want. So that works pretty well for a static installation, let's say, where you can say, I'll just run 20 slaves, one master, and this would be the way to do it on Kubernetes. But there is an even better way to do that, which is instead of using one pod for the Jenkins master, what we should be using is a replication controller. And just for one specific reason, that Kubernetes, or how Kubernetes manages replication controllers and pods. If a pod dies for whatever reason, Kubernetes is going to restart that pod in the same node always. But if the node dies, Kubernetes is never going to reschedule a pod in a different node. So if for whatever reason the node running or Kubernetes or Jenkins master dies, we would never be able, Kubernetes wouldn't automatically start that Jenkins master in a different node. So that's why Kubernetes recommends always using replication controllers. And basically, you just need a replication controller of size 1 with one master, with the Jenkins master container. And same as before, using a backup, using the data storage in Google. And when using multiple slaves, probably you don't want to predefine how many slaves you want, right? You want them to start on demand. Basically, whenever you have a job running, create a new slave on demand and run the job on that slave. So that's what the Jenkins Kubernetes plugin does. It will, from the master, it will create the slaves on demand based on the jobs that they are scheduled. And now, if you take that small picture with one replication controller for the Jenkins master and then slaves running as on-demand pods, if you want to run multiple Jenkins masters as soon as you want to scale, what CloudBees provides also is the CloudBees Jenkins Operations Center, where you could manage multiple Jenkins masters easily running on multiple replication controllers. So you could have multiple Jenkins masters, each of them having the X number of jobs and a specific definition for different teams, for instance. And those Jenkins masters could also have on-demand pod scheduling using Kubernetes. And same thing as the Jenkins master, it would be the storage would be in Google persistent disk in the case of Google Cloud. So Kubernetes Jenkins plugin is that plugin that can allow you to run on-demand slaves. This is a fairly new plugin from this year, and it's going through a lot of changes, as the same way Kubernetes is going through them. And it's basically allows you to run slaves on demand whenever you have them on jobs to run. So you can define any number of slaves using Docker images, and you can run jobs on those slaves, and Kubernetes is gonna start those pods running those containers, and it will schedule the jobs into those containers. So how does it do it? It actually uses pods instead of replication controllers, because you want to control specifically what slave you want to kill after a job is done. So you cannot do it with replication controllers. With replication controllers, Kubernetes basically manages the state. So you could say, I want 10 now I want 9, but you don't know which one Kubernetes is going to kill. So what Jenkins does with this plugin is manage each pod and kill each pod after the job is done. It uses the Jenkins Cloud API, which is the same API that the Docker plugin and other plugins do to schedule, or the AWS plugin to schedule slaves on demand. And it uses the Fabricate Java API to talk to Kubernetes. And it also includes preliminary workflow support for the Jenkins workflow plugin, so you can use Kubernetes slaves with the workflow plugin. And how it works, you go into the Jenkins settings after installing the plugin. You define where is the Kubernetes URL. In this case, because we are running Jenkins master and inside Kubernetes, we can use a few tricks there, because we know where the Kubernetes master is going to be, because we are using SkyPLS to find services. You could also paste the certificate keys and define Kubernetes credentials. So if you're using different Kubernetes clusters, you can change that here. And the interesting part would be at the bottom, where it says basically what images you want to run for different jobs. And you can use labels to define what image matches what job. So in here, what I'm doing is running the Jenkins CI Jnlp slave image, which is the bare minimum, and with no labels. So basically, it's going to run all the jobs in that container. And the roadmap for Kubernetes plugin is going to be providing a stable API as soon as Kubernetes Java library is also stable, and using new APIs that Jenkins provide to manage the slaves in a better way in the container world, because the cloud API was very designed for clouds, not as much for containers, and possibly using one new concept in Kubernetes 1.1 that is using jobs for like short-lived pods that execute some task. But we'll see when Kubernetes 1.1 comes out later this month. So with that, let me show you an example that is going to be there. So you should be seeing my browser here. I have a Kubernetes cluster running inside Container Engine with 3 nodes. 3 virtual CPUs, 11 gigs of memory, and basically just Google Cloud just gives me all the information about that. And I have running here 2 pods, one with Cloud-based Jenkins Operations Center, but I'm not gonna go into there now. And the other one is the Jenkins master. If I get the replication controllers, same thing. There's one for CJOC, there's one for Jenkins, and that's both of them have size 1. That's why there's only one pod of them running. And if I get the services, I can see that I have one service. So basically, I'm exposing the ports 80 and 50,000 of CJOC and 80 and 50,000 of Jenkins, and I can see both of them have an internal IP and a publicly available external IP. So I can describe services Jenkins. So this is the load balancer IP, what port is matching, what node port. So basically the service is exposing the port 80 to a port in the node that Kubernetes has randomly chosen. And it's going to the pod with this IP and this port. So this is how the service is working out all the way to the specific container running on each node. So external 80 goes to the node, to the 31,047, and that goes into the container port 8080 and the container with this IP. And the same thing for the slave port, the 50,000 port. And let's see now Jenkins running. So I have a Jenkins master server where I had 3 jobs. And I want to schedule, I'm going to run 3 builds. So you can see them coming up in the queue. And while that happens, I can show now that the Kubernetes Jenkins plugin has created a new pod that is actually doing a build. So this has been created by Jenkins, and I can see now if another one is getting created in a second. So basically, here it is. There's now 2 slaves running. I can see on Kubernetes. If that's the case, not yet. It takes a little bit from them to be scheduled and running. Actually, yes, there is a new one that was on status pending still, while the previous one was a different ID. And now there's 2 of them running at the same time. So basically, one started first, the other 2 came up right after. That depends on how Jenkins Cloud API decides how things are pretty much scheduled. And you can see them running, the 2 later ones here, and how they disappear as the jobs get done. And this is the piece of configuration that I mentioned, that I showed before as a screenshot. I can use what the URL of Kubernetes is and what the credentials. Because I'm running this inside Kubernetes, we also have an option that is basically using OAuth, and Kubernetes exposes as a secret the credential to connect to the Kubernetes master, so it's even easier. You don't need username and password. I can set how many containers do I want to have running at a maximum. This is useful in case there are some errors and you're trying and you know Kubernetes would be scheduling new and more containers, so you can cap that. And here would be where the templates are defined. And I can have multiple templates, so I could have this for jobs that have a label of, I don't know, like Java, and then maybe have a different template with more tools installed in the Docker image. And that would have that would allow Jenkins to choose different Docker images at the end for different job types. So this is how you would do it, creating multiple templates and defining different parameters for each of them. You can also customize the command run in the container and so on. And the definitions, similar to what I show on the slides. So this would be the master server is running one replica, is running this specific image that I created that has in this specific case, this actually is from another example, but it will be something similar. You choose a Jenkins image that you want to run, what ports do you want to expose, and in here I am mounting the Google persistent disk into, as I name it, Jenkins data, and here I reference it. And I'm saying put that into the Jenkins home folder. And Kubernetes also allows you to have like liveness probe, checking if the container is running, and if some port is responding, and if not, it would consider that service dead, and it would do something to fix that. I mean, it would kill it in that node and restart it somewhere else. So I think we thought that time is up. So I think it's time for questions.
Yes, it is. Carlos, that was fantastic. Thank you so much for taking the time to put together such a well connected and coherent presentation. And as one would expect, we have a decent amount of questions, so let's dive right into them. The first one is kind of multi-part here, I guess. They had problem putting it in, but how does the public key get to the Jnlp slave? Make sense?
Maybe. So the slaves, when Kubernetes plugin creates new slaves, it tells them what secret. It passes that as an argument to the Docker container running with the IP of the Jenkins master and the secret, so that a slave knows how to get back and has the secret to connect back to the Jenkins master.
Mm-hmm. Okay. Next question. How can I do this on, I guess it's on a Windows box or a Windows servers. How can I do this on a Windows?
Well, Windows has the same complexities as running in individual Docker. You would have to have, obviously you cannot run Docker on a Windows machine. You have to have a Linux VM running inside Windows. And I guess that's not very well suited to run Kubernetes on. Because if the question is whether you can run this on the native Docker Windows support that it's like in preview or something like that, the Microsoft guys are building this Docker Windows support. That's a very completely different issue, and that's really complex. But running Kubernetes on a Windows host is you will have to run it on a VM. Same thing with OS X. You cannot run Docker on Windows or OS X. You will have to use VMs. And running Kubernetes in VMs inside of Windows, that brings a lot of issues on how to network connect all these VMs that needed for a Kubernetes cluster.
Excellent. Next is not really a question, more as a comment, but Steve Speicher just wanted to say that RedHat has support for Kubernetes through a number of products such as OpenShift.
Yeah, that's correct. There's a lot of providers now that have Kubernetes offerings or support.
Okay. And then this one's probably not timely because we did the demo, but something to think about, and maybe we could do offline. How do you chain Docker nodes? Can you please show an example of the configuration file using multiple containers chained together?
Okay, so that's probably asking on whether if you can run one job in a pod with multiple containers, and that's not right now. It's not yet possible with this plugin, and I think there is very limited support right now for the Docker plugin too, that would allow you to do those more complex like Jenkins jobs. Like you want to test a web server container running alongside with a database container and do some sort of integration test with both of them running. That's not yet possible. I think there's some limited support for that too on the Docker plugin.
Okay. Where can you find complete documentation for this?
So the Jenkins plugin is publicly on GitHub hosted. The URLs are on the slides that will be published later on, and that's for the Jenkins plugin. The Kubernetes IO.io has a lot of all the Kubernetes documentation, and those are the two main places to look for.
Got it. Next, are there any Docker images for building Android APK and running Android emulators?
So how that would work is basically you have an image, a Docker image that has all the stuff you want, and you install the Jnlp jar in there and convert that image into a Jenkins slave. Or the other way around, you take the base Jenkins slave image and you install anything that you want to have installed, like the Android NDK, and you would use that image as the image for your jobs. And I don't know if there's, I think there are images for Android NDK, and it's not that hard to just add this Jnlp jar in there. Same, by looking at how the Jenkins Jnlp image is done, that's fairly easy. But it's at the end, I think there's a lot of people that will create their own images because there's no build image that fits all.
Okay. Next. What are the disadvantages of Kubernetes?
Well, I guess that's maybe comparing with something else. So Kubernetes, one of the problems with Kubernetes, it's not trivial. It's not trivial to install. That's why Kubernetes Container Engine, Google Container Engine, and other services I think are going to be very popular. It's not trivial because you have to deal with all these a number of nodes, installing software on them, then handling persistence, disks, and things like that, and then network isolation. And that's not a trivial problem to solve, and it's not trivial even with Docker. So, it's a complex project, but if you have it running, then it's from version 1.0 it runs pretty well. There was issues before 1.0 became public, but in Google Container Engine runs pretty well.
Got it. Our next question is, can I use this setup if my builds generate Docker images as artifacts?
That's a very interesting question. There is actually now a PR, a pull request, asking to do that because running there's two options to run or create Docker images within Docker. So one is running Docker in Docker, which is not very nice, and people advise against that, even people that created that, Docker Inc. And then the other option is to use the same Docker server that is used in the host. And there's a PR to be able to do that and mount the Docker host, Docker server inside a container and do all that sort of magic. And there's the only problem you need to be aware with that is that you need obviously to trust the containers running and that because they're going to have access to the Docker server. So as long as you trust them, it's okay. It's not too hard to do. There's a PR coming to do that in the Kubernetes plugin specifically.
Got it. No, this one's a little after the fact, but Jonathan Baker was interested in seeing some examples of an Elasticsearch Kibana configuration. Carlos, if you want to maybe offline or if you can get something, a pointer to it, I'll post it.
I didn't get into that, but basically with the command line, you can just do the kubectl command line. You can do kubectl logs on any pod, and then you get the logs from that container, and that comes from all this infrastructure that Kubernetes has set up for you. All the it does aggregation of logs and everything, so you can easily get the logs of any running pods.
Excellent. Next, where are the Docker images and YAML files located for this webinar?
All the examples, they're in GitHub, and it's on the previous slide, and but that will be, they are under Carlos SG Kubernetes Jenkins.
Perfect. Okay, next question. Is there any preparation to do on the physical node? For example, var/Jenkins_home. Is it referring to the node mount point, or is it referring to the containers?
No, if you use like distributed storage, like Google Cloud disk or an Amazon disk or ClusterFS or anything else, you don't need to do anything on the host. Only if you do host mounting volumes, that's when you need to prepare the host. But obviously that's more for like testing, because that's not going to scale. If your pod moves to another node, your host volume is not going to be there. So that's only pretty much for testing. As long as you use a distributed file system, there's nothing to be done on the actual node for the Jenkins Kubernetes plugin installation. Right.
Got it. Okay, next. This is a longer question. Do you have a design pattern that works well to run cron type tasks in Kubernetes? With Mesos, one can use Kronos. Are there patterns to use Jenkins to execute a Docker container on a cron schedule like one can with a regular Jenkins job?
So the way this works, if you use the Jenkins Kubernetes plugin and you schedule your job, then whenever your job needs to run at whatever time, a new slave is going to be created for that job. So you just basically use Jenkins cron expression for that, and that's done. I guess that's probably the question. Yeah, because you could have. Yeah, I guess that's. I'm not really understanding that, but maybe that helps.
Okay, I hope. Okay. All right. Where can I find Docker images and YAML files using this webinar? I thought we answered that one already, and it's up here on the site with the URL. And then we had two questions. How does Kubernetes relate to Docker Swarm or Apache Mesos? How does Kubernetes relate to Docker Swarm or Apache Mesos? Yes.
Yeah, so they both, of the three of them, are container schedulers. So Kubernetes provides like a higher level API with all that I show, provides persistence, provides network isolation, provides this state of managing how many instances you have running with replication controllers. So that's the higher level API that other things don't provide. Now, Apache Mesos is another scheduler, and it works pretty well. I use it every day. And it's not competing with Kubernetes. I mean, you can run Kubernetes on Apache Mesos. Basically, Apache Mesos, it's more like, provides you more like lower level APIs. And you could, there's a project to run Kubernetes on top of Mesos. So it would provide you all that replication controller capabilities, pods, and so on. And Docker Swarm is the latest one that arrived. It's more about expanding the same Docker API to multiple hosts, and it doesn't provide you as many added features as Kubernetes. So it's basically more about how using the same Docker API across multiple hosts. So they're a bit different, each of them. They could all work doing the same things. I mean, there are Jenkins plugins to manage the three of them, and you use a Docker plugin with Swarm. You can use the Apache Mesos, the Mesos Jenkins plugin with Mesos, and they cover different use cases, I guess, and at different levels of abstraction.
Excellent. Okay, last question. How does this plugin differ from the Docker plugin?
So yeah, so basically this plugin uses the Kubernetes API. So it allows you to manage or abstract all that complexity that Kubernetes does behind the scenes. The Docker plugin by default is just to use one Docker host, while with Kubernetes you can use multiple ones. Although the Docker plugin recently had added the support for Swarm, so you could also do a scheduling across multiple Docker hosts. So they are fairly similar. Then it's just basically if you have a Kubernetes cluster running, this is the one you would use. If you want to have Docker Swarm running, you could use the Docker plugin.
Got it. You know what? We did get 2 late questions, but we're really not going to have time. Jules, I'm going to ask if you could grab those in writing. We'll submit them to Carlos and see if we could get some answers when we post the recorded version of this. But we are respectful of everyone's time, and we are over the hour, so we're going to have to call it right here. Carlos, again, thank you for a great presentation on a very, very interesting subject. I don't have any complaints. People saying it wasn't technical enough, which is always good. And we'd love to have you back on to revisit this as you could continue to develop the plugin and functionality. To all of those who've stuck around here to the end, thank you very much. We hope you enjoyed it. I'm sure you did. This is Alan Schimmel for DevOps.com. Thank you very much for CloudBees, to CloudBees, for sponsoring today's webinar. Again, another great one. And we will see you again on the next, hopefully, DevOps.com webinar. This is Alan Schimmel, and have a great day.